This is the 2012 F equals MA contest, and this is problem number 20. So we're given that we have a scale, and upon the scale, we have some water in a container, and the scale initially reads 45 kilograms. Another scale has a reading of 12 kilograms, and it's suspending this block of wood. Now we're told that the density of the wood is equal to 0.6 grams per centimeter cubed. And we're told that the density of water, or namely the density of H2O, is equal to 1.0 grams per centimeter cubed. Now we're told that we have this same container, but now we're going to submerge our block so that half of the block will be above the water and half of the block will be submerged in the water. And now we're asked to find the new readings on our two scales. So let's call this one M2 and we'll call this one M1. So a few things to note here. Let's draw a free body diagram for our object in the water. It has the force of gravity acting upon it, Fg, because it has mass. It also has an upward force from the string that's pulling it upward for the scale. So let's call that F2. Another force is actually the buoyancy force. We'll call it Fb. And the buoyancy force is from the weight of the water that our object has displaced. So namely, we have that the buoyancy force will equal to half of the volume, since it's only half of the volume that's underwater. So let V equal the volume of our block. So half of the volume times the density of H2O. This gives us the mass of the water displaced times G. And this will give us, once we have times G, it will give us the weight of the water displaced. But now we need to find V. So in order to find V, well, first off, we know that the mass of our block of wood is equivalent to 12 kilograms. Now volume is just equal to mass over density, since density is defined as mass over volume, so mass over density gives us volume. So we can plug it in to get 12 kilograms over the density, which is 0.6 grams per centimeter cubed, but now we want to convert this to kilograms, so we have that in 1 kilogram we can get 10 cubed grams. And so this equals namely 20,000 centimeters cubed. So when we put that into our equation for buoyancy, we have that 20,000 centimeters cubed divided by 2 times the density of our water, which is 1.0 grams per centimeter cubed. And we also want to put grams into kilograms, so once again we convert by saying there are 10 cubed grams in 1 kilogram times gravity, which we can approximate here to be meters per second squared. And we have that 20,000 divided by 2 is 10,000. 10,000 divided by 1,000 is 10, times 10 is 100. So we find that this equals 100 newtons. Now because here we know that our block is at rest, that means there has to be no net force acting on it. So the downward force, namely the force of gravity, which is just the mass, 12 kilograms, times gravity, which is 10 meters per second squared, has to be equal to the sum of the two upward forces, namely F2 plus Fb. And we know that Fb is just equal to 100 newtons. And we're trying to find F2 because we know that F2, its relationship with F2 is that with M2 is that it is M2 times G. And once we find M2, we can find M1 again, because we know that M1 plus M2 must equal to the total of 12 plus 45 kilograms, which is also to say 57 kilograms, since we know that no mass has been lost or gained when we go from here to here. And as a result, this must remain true. And so when we multiply 12 times 10, we get 120 newtons is equal to F2 plus 100 newtons. And thus we find that F2 is just 120 minus 100 newtons, which is 20 newtons. And this is equal to M2 times G, and we know that G is 10. So when we divide by 10 on both sides, we get that M2 is just equal to 2 kilograms. Since M2 is equal to 2 kilograms, and we know that M1 plus M2 equals 57 kilograms, then we find that M1 is just 57 minus M2, or in other words, M1 is 57 minus 2 kilograms, so it is 55 kilograms, while on the other hand, M2, like before, is 2 kilograms. And now let's consider if this makes sense. That means that M2 has gone from 12 kilograms to 2 kilograms, which means it has gotten lighter, which it has, and it makes sense because instead of solely supporting the block with the spring, there's also an additional buoyancy force that helps lessen F2. Now let's consider M2. M2 goes from 45 kilograms to 55 kilograms. And so we find that M2 actually increases, which makes sense since now it also has to accommodate for the part of the force of gravity upon the block, since the block is now in the water and the water is in the container and the container is on our scale. So we say that M2 decreases, and there should be M1 here, and M1 increases, and both of which seem to make intuitive sense. And as a result, we state that yes, M1 is equal to 55 kilograms and M2 is equal to 2 kilograms, and that's our answer.